Okay, hi guys. So here's the B-10 video. And so this is the example that we're about to do. So what information would we need to show that Q of R equals 5 for some R 0 less than R less than 7? All right, so before we do that, this is from last year, and I'm gonna paste this into your complete notes. All right, so the intermediate value theorem. So here I'm going to give you the formal intermediate value theorem. So here's a picture which we'll look at in a moment, but here's the IVT. If W is an intermediate value for f of A and f of B, and f is continuous on the closed interval A to B, then there must exist a value C where A is less than C is less than B, for which f of C equals W. All right, so we've got here's this. So we've got this interval A to B. All right, there's that interval A to B. Here's the outputs at the endpoints. Okay, so there's f of A, there's f of B. As long as we have a value W, okay, so here's the y value W. As long as we've got this y value W between the outputs at the endpoint, so as long as this y value W is between f of A and f of B, so that's condition one, and f is continuous, okay, so there's no breaks, f is continuous on this interval A to B, including A and B, so closed, then there has to be this value C between A and B for which f of C equals W. All right, so that's what it looks like as a picture. Now, if we're going to explain using the intermediate value theorem why a function takes on a certain value on a certain interval, then we could use this like outline for it all the time. Okay, we already used this outline previously. So basically you state f of A equals blank, f of B equals blank. So you state the outputs at the endpoints of the interval. You state that whatever value you're trying to prove that f takes on, you say that it's an intermediate value. So W is an intermediate value for these, meaning it's in between them. And then you've got to bring in continuity, because if f isn't continuous, okay, if there's any like breaks or gaps here, then we can't guarantee that this works. So since f is continuous on the closed interval by the IVT, and the AP people, if you say IVT, the AP readers, the ones who are reading your test at the end of the year, they're going to know you mean intermediate value theorem. So you can abbreviate that. So by the IVT, there exists a number C, between A and B for which f of C equals W. All right, now this is going to be really fast. Okay, so what we're trying to get you to do here is just basically know the conditions, be able to state the conditions of the intermediate value theorem. So what information would we need to show that Q of R equals 5 for some R between 0 and 7? So you need these two conditions. So one, you need to be able to say that 5 is an intermediate value for, and then you need this number to be in between the outputs of the function at the endpoints of this interval, so at 0 and 7, for Q of 0 and Q of 7. Okay, 5 is an intermediate value for Q of 0 and Q of 7. Okay, so that gives you this part. Okay, that the number, the value you're trying to show that the function takes on is between the outputs at these endpoints. All right. So that's condition 1. And these could be like reversed. But number 2, you need continuity. Okay, so Q is continuous. CTS is a fine abbreviation for continuous. Q is continuous on this closed interval 0 to 7. All right. So yeah, so these numbers here 0 and 7 are the same as this 0 and 7, and this needs to be a closed interval. All right, guys, that's it.